Hey there, science explorers. Welcome to today's lesson, Pressure Power. Our science objective today is that science explorers will conduct investigations to understand that air has weight. Air is all around us, right? We can't see or hear air. So, how do we know it's there? Take a second. Think about that. How do we know that air is there? Well, we know that air is very important for living things as humans and animals need air to live, right? We need to breathe it, okay? The air we breathe is actually a mixture of gases. Air contains approximately 78% nitrogen, 21% oxygen, and small amounts of other gases, including argon, carbon dioxide, and hydrogen. The air that surrounds our planet is known as the atmosphere. The atmosphere is made up of layers. The first layer, closest to the Earth, is the troposphere. This is the layer where all weather occurs. The second layer of atmosphere is the stratosphere, and it contains our ozone. Ozone is considered a pollutant at ground level. But the ozone layer of the upper atmosphere protects life on Earth from the sun's harmful ultraviolet radiation. The stratosphere is the layer of the Earth's atmosphere where planes fly. The next layer is the mesosphere, which is the coldest layer. The final layer is the thermosphere. This layer is the highest and can reach temperatures greater than 1,750 degrees. This is due to the oxygen in this layer being absorbing most of the sun's harmful ultraviolet rays for us. So, thank you, thermosphere. There are some basic rules for air. Okay? Air takes up space. Take a deep breath. Your lungs, right? Your lungs, when you breathe in, they fill up with air, right? So air does take up space. Air has weight and pushes in all directions. Air may seem like it's light and doesn't have weight, but that's not the case. Our atmosphere extends 50 miles above the Earth, and all of those layers of the atmosphere are pushing down on Earth. This is called air pressure, and it has been measured at 14 and 7/10 pounds per square inch at sea level. This means you have 14 and 7/10 pounds pushing on every square inch of your body. This is as much force as the weight of an elephant. Air pressure is greatest at sea level, which is the lowest level on Earth. And the pressure gets lower the higher you go because there's less atmosphere pushing down. This means that air pressure on top of a mountain will be less than the air pressure at the bottom of a mountain. You may have experienced the difference in air pressure if your ears have ever popped when you're, like, say you're driving in a car and you're going up a mountain or a hillside, or even taking off in an airplane, or yeah. So your ears might have felt funny, and you had to swallow really hard to make them pop. When air is compressed, its pressure increases, believe it or not. We can actually increase air pressure by placing a lot of air into a small amount of space. For example, we pump air into our car tires in excess of 14 and 7/10 pounds per square inch. With this increased pressure comes strength. 4 tires filled with air are able to hold a car, its passengers, and contents. Air always tries to move from a place of higher pressure to a place of lower pressure. When under excessive pressure, the air molecules look for a way to escape. This is evident every time we blow up a balloon and accidentally let go. I know my daughters love to do that, right? They go, okay? The air rushes and escapes its high pressure space inside the balloon and enters into a low pressure area outside of the balloon. When air is heated, it expands, and when it cools, it compresses. Heated air expands and thus takes up a greater amount of space. Just the opposite is true for cold air. When air is cooled, it will take up less space. Think in terms of a hot air balloon. This is why hot air is continually added while flying, because as the air cools down, less of the balloon space is taken up. So you need to keep adding that hot air to keep the space filled. Okay. So with all that brings us to activity number 1. Remember we talked about balloons. Now we're going to do an experiment called balloon bottle. Activity number 1, balloon bottle. So science explorers, it's as simple as you're going to get a bottle, right, and a balloon. Now, science explorer instructors, beforehand, you guys are going to pre-puncture a hole at the bottom of the bottle. What we did was we heated a metal screw with a lighter, and then it was able to poke through pretty easily to get that in there. Something that you can still cover with a fingertip, and you'll see why. So here's what we're going to do. To model some air pressure, we're going to take our balloon and we're going to stick it inside the bottle. All right, don't drop it all the way in, because what we need to do is we need to take our balloon and wrap it around the cap there. Man, Dada Dietrich made that look pretty easy, right? Just stretch it out, pull it over, and there it is. Now we got a balloon in a bottle, okay? What your first activity is going to be is that you're going to take the bottle, you're going to try to blow the balloon up, all right? After I get the balloon blown up, I want to try to put my finger over that hole. And then, what do you think is going to happen? Do you think the balloon will deflate? That's what our brains probably tell us, right? Here we go. Let's give it a shot. Here we go. Ha! Finger over the hole. Balloon is still blown up in there. Isn't that interesting? Look at that. I could put candy or something in there now. But there you go. Why is that happening? I have my fingers over that hole, right? When I blew the balloon up, it was able to force whatever air that was inside the bottle out of the bottle. And I covered it with my finger, and now it can't take that air back in to let the balloon deflate. What do you think is going to happen when I take my finger off the hole? Well, there's only one way to find out. I believe it will deflate. Here we go. Ready? 3, 2, 1. It did. It deflated, right? All the air was able to go back through that hole and come back into the bottle and allow the balloon to deflate. Pretty interesting the way that pressure works. We're going to try it the reverse way now. We're going to try by putting our finger over the hole and trying to blow up the balloon. Do you think I'll be able to do it? We'll find out. Here we go. Ready? Yeah. I'm getting red in the face. Probably. It's not going to do it. It won't allow it. Why? Because there's nowhere for the air that's inside of the bottle to escape. So it makes it quite impossible to blow that up. Okay? Try as you might, it goes just a little bit what's already there, but you're not going to get it as big as you had it before without your finger. Pretty cool, right? Ooh, it's a green bottle. No, it's not. So it's all about the air pressure in there. Pretty amazing science. Let's go take a look at activity number 2, which is our marshmallow bottle demo. Activity number 2, marshmallow bottle demo. All right, Science Explorers, activity number 2, it's our marshmallow bottle demo. We have a bottle with some marshmallows in it. Science Explorer instructors, you're pre-filling this to save some time at camp. So there's our marshmallows. You're going to have our fancy little fizz keeper bottle cap, right? And what this does is when you put this on a soda bottle or something, you're able to pump it, and what it happens is it forces air into the bottle, and it helps keep your drinks fresh longer. And you're going to need some masking tape. So what we're talking about here is compressed air. And what we're going to do is we're going to be compressing some air into this bottle. Where do we see compressed air in our lives? Well, you see compressed air in the balloons, the balloon activity that we did. We're compressing air, right? Your bike tires on a bicycle, they have compressed air. With the increased air pressure comes strength. And when you compress the air into something like that, it gives it extra strength. It makes it harder. So right now, this bottle, you can squeeze it. And even after we take our Fizz Keeper lid and we put it on, and we'll make it nice and snug, okay? It's still soft, see, right? There's the air that was in there, but it's not as much as you would think there was. So what we want to do is we're going to be using this. We're going to be compressing some air into here, and we want to see what happens. We're going to use a piece of masking tape to mark off where our marshmallows are at first. So I think that's pretty good, right? All right, so you and your Science Explorer partners are going to take turns compressing the air. You're actually going to have to pump this thing about 100 times. Yeah, you heard me right. 100. 100 times. You're going to pump this bottle. You can take turns. You can count out loud. You can pass after 10. You can pass after 20. Whichever feels best for you guys. I'm going to have you guys pause the video, do your pumping, and then come back and we'll take a look at this bottle together. Well, Science Explorers, I don't know about you, but I've been pumping for quite a while. And my Fizz Keeper, I just keep pumping and pumping and pumping. And what's supposed to happen when you pump this, I've pumped it well over 100, probably closer to 1,000. I'm getting a good workout in. What's supposed to happen is your bottle's supposed to get harder. It's supposed to pressurize this and push the air molecules inside. And as the air molecules are forced inside of the bottle, the air pressure will push the marshmallows down and you would see them visibly drop down. As in most other science projects that go wrong, I have a faulty pump, it's just not working right. What's supposed to happen, again, is my marshmallows are supposed to go down. And no matter how much I've pumped for the last 10 minutes, that hasn't seemed to work for me. But you're forcing the air molecules in, so I'm hoping that it's working for you. You're forcing the air molecules in, and you'll see the marshmallows get compacted because of the air pressure. It's pushing it down. And then, if you would open it up, you would release the air. You would hear on your end, if your pump's working correctly, you'd hear a shh, right? Almost like you're opening up a soda. And then when you open it up, you would give it a little bit of a shake, and your marshmallows would come back up and they wouldn't be compacted so much anymore. Again, it all had to do with air pressure, and the high pressure was compacting your marshmallows. Hopefully yours worked out better than mine. Let's move on to activity number 3, where we're going to try to lift an object with air. Activity number 3, lift an object with air. Whew. All right, Science Explorers, here we are in our next activity, activity number 3, where we're going to try to lift an object with air pressure, okay? You're going to get a Ziploc bag, which you will put your name on, Daddy Dietrich. You're going to get a straw, right? You're going to need a heavy object like a book or something that you can lift. I'm going to use my Chromebook. Why not? Let's see what happens, okay? And this activity is pretty simple, okay? We're going to open up our bag, and we're going to stick one end of our straw in it. You're going to try to seal it up as tightly as you can. And what you may need is, some of us might need some duct tape to seal it up. I think we could probably experiment before we use the duct tape and see if it works without it. But here we go. I'm going to take my heavy object, which is a Chromebook, right? It is a functioning Chromebook. It's not just a cardboard box. I'm going to put it on the plastic bag. I'm going to make sure that my zipper here is closed. And I'm going to blow into this bag. And we're going to try to lift up the Chromebook. Here we go. You ready? Ah! Oh man, he slid off. But do you see it's lifting it? All right, let's readjust. Let's get it here. Now, if you hold your finger over the straw hole when it's up, it will. It's gonna stay there. As I let it go, the air pressure is released. And it drops back down. That's fun. It's a fun way to see how air pressure can actually move objects as well. Okay, let's go check out activity number 4. Activity number 4, Spud Launcher. All right, here we go, Science Explorers. Activity number 4, our little Spud Launcher. You're gonna get a piece of PVC piping. You're gonna get a dowel rod. You're also gonna get 2 slices of half-inch thick potato. What we're going to do is we're going to model how the air pressure between the pipe can, cause the potato to launch. You're going to also have colorful masking tape to decorate your PVC piping. I can't take credit for this. Somebody else decorated it for me. I thank her so much. But you're going to be able to decorate your PVC piping. You're also going to get a Science Explorer label telling you what it is. And you'll be able to take this home with you today. It is pretty thick. But here we go. So here's our dowel rod. Here's our potato. Ready? It's like one of those Instagram videos. Ready? Oh wait, it didn't work out well. But here, I cut it already. I pre-cut it. Look, now it's a smaller potato. We have our 2 half-inch thick pieces of potato. What we're going to do is we're going to take each end of our PVC pipe and we're going to take it and really get that in there. Oh gosh, this is going to be pretty interesting. Yeah. So now we got it on one side, right? We're going to take the open end. We're going to do the same thing on the other. Ready? Here we go. And it's in there, like swimwear. And it didn't even mess up my decorations, which is the best. So we have potato on that end and potato on that end. There's the moment of truth. What we're going to do is we're going to take the dowel rod and we're going to push one end of the potato up. What do you think is going to happen? I'm a little nervous, but here we go. Ready? Pop goes the weasel. That was pretty cool. I didn't expect it to go so high. What happened? What happened? Oh my gosh. What happened was there was air pressure, there was air, which is a gas that was trapped between those 2 pieces of potato. And as we pushed one end of the potato, as we pushed it through, it pressurized the air. And after a while, it just couldn't take anymore. And that other end of potato shot out and hit my ceiling. I should have probably did this outside. But that's pretty fun. If you have more potatoes at home, you can recreate the experiment. You're going to be able to take this stuff home. There's my other chunk of potato right there. Maybe you can make something out of these and eat it. I don't know. Who knows? I'm going to go pick up that potato off the floor, and then you guys can come join me for activity number 6, which is straw rockets. Activity number 5, straw rockets. All right, here we are with our final activity for today. Activity number 5, straw rockets. You're going to get a straw. You're going to get a piece of paper that's going to turn into our rocket. And you're going to need a pencil here to help us roll up our rocket. what you're going to do is you're with your Science Explorer partners, you're going to share some crayons, or if you have your own art supplies, you can use those. And you're going to color your and design your rocket. After you're done doing that, you're going to take your rocket or your rocket paper, and you're going to roll it around a pencil. Okay, and try to make it nice and snug to the pencil. You're going to roll it around, and then your partner can probably help you tape this then. Okay, and you're going to tape along that seam going down. When you take it off, you'll fold or pinch one of the tops and then tape it again. And you're going to end up with a product that looks like this. Wow, that was magic. Go away. You don't exist. So now we have our straw rocket, all right? Since the pencil is a little fatter than the straw, it should slide over the straw nice and easy. And then we're going to launch it. Ready? Hey, there it goes. All right, how about that? Ready? All right, Science Explorers, that's it. That's all we have for you today for Pressure Power. Join us again for another lesson in the future. And as always, here at Science Explorers, if it's not fun, we're not doing it. Oh.